Hey folks, it's Andrew Kilpatrick here, and welcome to MIDI Part 2. Today's topic is called MIDI message types, and I've made a list of some points to cover in this video, so let's get right into it. So there's four main points that I want to cover today, talking about message types. We'll get into the specific message details later on in a future video, but these are the main 4 points that I think fit, which is that MIDI is an event-based protocol. We'll talk about what that means. Channels versus system messages. Omni and Poly modes. These are a little bit old-fashioned, but you still will run into it from time to time. And also local on and off. And if you're new to using hardware synthesizer keyboards with your computer or with another sequencer, then this is an important point. So let's go over to the bench, as usual, and we'll get right into it. So, MIDI message types. The first point that we need to cover is that MIDI is an event-based protocol. And what do we mean by that? Let me give you an example of the opposite of an event-based protocol, and something that we're probably all familiar with, which is video interfaces like VGA, HDMI, DVI, and things like that, or just plain old TV, composite video signals. So in a video signal, we've got a screen. We've got pixels going across the screen. These are lines of pixels usually. And normally, the video signal sends each line one at a time from left to right and then from top to bottom of the screen. And then when it gets to the bottom of the screen, let's say that's 1/60th of a second, if we're talking about 60p type of a video signal, it goes right back up to the top and starts all over again. So if there's nothing changing on the screen, this process is still happening. So in your tablet or your laptop, the LCD screen that's attached to the motherboard is getting continuously refreshed with this data. Same with your HDMI signal, the pixels are being sent over and over, even if nothing's changing. So to change a pixel on the screen, all we have to do is go into the memory and change a value somewhere. And now, the next time that screen redraws, we'll see that new pixel on the screen. And that means one main important point is that you could plug in your video cable at any time, and this screen image will appear in its entirety. There's no need for the TV to remember what the screen looked like before. It gets an entire new frame every time. That's different than an event-based protocol like MIDI, where the receiver, or let's say the synthesizer or the sequencer that's listening to a keyboard or something like that, that device is responsible for remembering the state of everything that's been happening in the past. So what that means is that it has all kinds of memory registers and things that it keeps track of which notes are held down, and it keeps track of the knob settings, and so on. And that has a bit of an implication in using MIDI in a real situation. For instance, if we push down a note on our keyboard and then we plug or unplug the MIDI cable and then let go of the note on the keyboard, the synthesizer that's connected was connected will continue playing that note forever, possibly, because it never got a chance to see that the note was stopped. Also, on the contrary, if you press down a note and then plug in a synthesizer, that note's not going to automatically just start playing because that event happened and it's in the past. So that's a really important point to remember about MIDI, because it sort of affects how we use MIDI in sort of a timeline kind of approach. In a MIDI sequencer, if you zoom in and you look at all the details under the hood, you'll see that all these events happen at a specific time. The only thing things that have lengths in, let's say, a MIDI sequencer would be notes. And that's really just the sequencer's way of saying, well, I'm going to start the note, at this point and stop it at this point. Like if you're looking at sort of a piano roll view in most modern programs. It's like, I'm going to send an event here, and then I'm going to wait, and then I'm going to send another event here. So this is the on event, and this is the off event. But during this time, nothing's really happening. And that's an important point, is that things don't get sent unless there's something changing. So if nothing is being sent, it just means that whatever state we're in right now is the state that we should stay in. And that's basically how that works. So the next point is channel versus system messages. So anyone who's used a MIDI synthesizer probably knows a little bit about channels, or at least has seen that that's what that's all about. Channels and system. So let's talk about channels first. In MIDI, one cable, when we talk about a cable, we mean sort of the traditional 5-pin DIN plug, or one port on our USB interface or whatever. We covered that briefly in the last video. A channel carries information about a specific part of a performance. Think of it like a track, sort of like a track, or like a specific interface to a specific sound on an instrument, a specific audio channel on your mixing board, maybe like the drums are on a certain channel, the bass is on another channel. Don't think of mono and stereo, that doesn't really apply here, but in MIDI there are 16 channels. They're numbered 1 through 16, like that. Some other things in MIDI start at 0, and we'll get into that later. It's a little bit confusing, but for the most part, when we talk about channels, we talk about channels 1 through 16. Channel events are most of the events that we use sort of when we're doing a performance. They include things like notes, which includes note on as well as note off. Those are two different messages, although there's some little subtle details that we'll cover in another video. CCs, or continuous controllers, sometimes it's called. The correct name is control change, I believe. Those are basically one and the same. That's basically knobs. The damper pedal, if you are playing like a piano. Other kinds of things where you want to have a value associated with a knob or a button or something like that. Most controllers that have just general purpose buttons and things send control change messages when you press the buttons. Usually when you press down, it sends one value, and when you let go, it sends another value. What else? Pitch bend. That's another one that exists in channels. And there's a few others as well, like aftertouch and things like that. But channel messages are associated with a specific channel, and when the message is sent, they're always tagged with a specific channel number. And that means that you can have up to 16 different parts, all with different state, as we talked about our sort of event-based state before. And they can all sort of coexist on the same port or the same cable without interfering with one another, so that you can control one instrument with one channel, one instrument with another channel. Because MIDI supports the concept of a through connection, you can actually have two instruments playing from the same channel. Let's say you just want to have two parts, doubled up with the same notes. You can totally do that as well. System messages are a little bit different. As the name implies, they sort of cover things that affect the whole system. Things like active sensing, that's one that's not really used by the end user, but it's used by systems sort of detect that things are plugged in and things like that. Some devices send a pulse, like a heartbeat. That's a system message. System exclusive, which is used by manufacturers to send specific kinds of data. For instance, like firmware updates or specific sort of patch dumps and things like that. That's SX data. And the other main one that we probably are all familiar with has to do with clock. MIDI clock being used to send timing information, let's say from a drum machine to another sequencer, or from your computer to a drum machine, things like that. MIDI clock is a system message. So these don't have a channel. There's sort of subsets of system messages, which we'll get into in another video. These don't really have a channel at all. They're just sent and everything receives them. And remember, in MIDI, if an instrument or a device doesn't know about a specific kind of message, it just ignores it. It doesn't do anything. So it's okay to have a clock message be received by a synthesizer that doesn't have a sequencer, because the synthesizer will just throw that message away and it won't get used. But let's say we connect up through connection and plug it also into a drum machine that does know about clock, well, then it can interpret the clock messages and do whatever it wants with it. So that's basically the two major classes of MIDI messages. And then there's two other small sections that we need to cover, just so that we're, being complete here. One is Omni and Poly. These are sort of two things, but they're sort of grouped together if you read the MIDI specification. Omni and Poly are sort of older concepts. They're not that much used anymore, but you will see some evidence of that, especially in music programs like sequencer software and DAWs. Omni is like a setting that can be on or off. So Omni can be on or off. And what that means is, just like we just spoke about channels, Omni means that a receiver will ignore a channel and just respond to all the channels, or it will respond only to a specific channel. And so that's used basically, a common example is, let's say you plug a MIDI keyboard into your DAW software. Normally, if you say, I want to use this MIDI input to control my DAW, I've got my keyboard here, I've got my computer over here with my DAW on it, and I want to control my DAW software with my MIDI keyboard. Normally, it doesn't matter which channel this keyboard is sending notes on. Normally, the DAW will just respond to any channel. Now, you may be able to turn off certain channels or filter them in different directions, but generally, it would just respond to all the channels, because normally it doesn't really matter. The channel here doesn't mean anything to the DAW, because the DAW is just going to go and send out another channel to whatever instrument on the track you have selected. So that's an example of Omni being on in the case of the DAW. It doesn't care about the channel. Most synthesizers that are going to respond to MIDI notes and make sounds are only going to respond on a specific channel. They may not even have a setting for Omni. So that's an example of Omni being off. Older keyboards had settings in the menus that let you change that. It's not really that applicable anymore. Normally we would just use a channel for everything if it's a channel message, and actually, specifically set our sender and our receiver to the same channel. The other thing is poly mode. This is also a little bit of an old-fashioned thing, and I'm not actually sure I've actually ever used this for anything, but this is something that exists in MIDI, so I guess we'll talk about it. And this has to do with whether a synthesizer will respond to multiple notes at the same time or not. And this also has a setting that's on and off. And this sort of means that you could use a polyphonic synthesizer as a monosynth. And that's kind of interesting, I guess. I don't know, you'd have to look at the manual for each synth to see whether it even supports that and what it will do with those notes if it receives multiple notes when it's in poly off mode. But that's kind of interesting. I don't think I've ever used that for anything. Polyphonic synths usually respond polyphonically. Certain patches I have seen on synths where they'll operate the synth in a sort of monophonic mode if they're trying to make sort of an old school, like a lead synth sound. You might want it to respond so that when you hold down a note and press another note, it will switch to the other pitch. But that seems to me, from my experience, is more to do with the patch on or the preset on the synth rather than sort of a global synth setting. Anyway, that's Omni and Poly. And the one other thing that we should cover in this video, because this is really important and it's something that you pretty much need to know if you're going to use external keyboard synths with a computer or a sequencer, which is local mode. And so let's talk about a typical sort of keyboard style synthesizer. So a keyboard synth is really kind of two things in one. So we've got our keyboard here with our keys, and we can sort of draw a dotted line. And back here we've got a synth. There's actually two parts to a keyboard synth that actually makes its own sound. So if you bought a MIDI controller, which is sort of just, like no sounds in it, connects to your computer or to some other instrument, you kind of only get the bottom part. You get the keyboard that sends out MIDI. If you buy a MIDI module that sits on the table that doesn't have a keyboard, you kind of only get the top part. But when you buy a synth that comes with a keyboard and everything integrated, you basically get two things. You get a synth and you get the keyboard. And normally, when you just switch it on and you want to play it, normally the keyboard sends MIDI, but it's not actually going outside. It's sending it internally. There's MIDI being sent between the keyboard and the synth so that you can just obviously just turn it on and play. But that presents a little bit of a problem when we want to use it with a sequencer or a DAW. So here's our DAW over here. And we want our DAW to record the output from the keyboard, and we want it to then be able to play back the sound of or the MIDI events and cause the synthesizer to make sound, it being controlled by the DAW instead of the keyboard. So local mode affects basically whether this internal connection is on or off. If local is on, then this synth will send its own MIDI messages to the keyboard will send to the synth internally without any external anything being required. But if we're sending our MIDI to the DAW and then back to the synth, which is sort of the normal way that you will use a DAW to sequence external hardware, is that you don't want this connection to be on, because then otherwise the synth within your keyboard is going to receive two MIDI messages. It's going to receive its local one here, and it's going to receive one that's been sort of looped through the DAW when you've got this same track selected. And what that will do is, let's say on a polyphonic synthesizer, it'll use up twice as many voices, because it will start a sound here and then it will get another note event saying start another note. It's actually the same pitch. A lot of synths will just start two notes with the same pitch. And if you ever hear this sort of weird chorusing sound that sounds like kind of two things playing in unison, then that probably means that you've forgotten to turn the local mode off. So if you're looping it through here, turn local mode off. It's usually in the menu on the synth, or there's usually some button combination. And that will kill this connection here. And then if you unplug the MIDI cables and you play your keyboard, you shouldn't hear any sound coming out. Then if you just loop a MIDI cable back to itself or plug it through your sequencer, then you're going to start to hear the MIDI messages having been routed through your DAW or your other sequencer or whatever. So those are the sort of high-level concepts of the messages, channels, Omni Poly and local and so on. So I hope that you learned something from that, and I hope that you'll join me on the next video. I have a bunch more videos, and I've figured out a bunch of topics. Hopefully that you're learning something from this. Please make comments below the video, and like and subscribe so that you can keep following along. I'm going to add each of these to a playlist as each one is finished. So if you want to see the whole series once we're all done, then just check for the playlist on my channel. Thanks a lot. See ya.